I'm Daniel Lyon. I'm one of the CAM specialists at Hawkridge Systems. Basically, today's webinar is going to be a bit of a mix of stuff. A little bit about the background about what's going on in the industry as a whole. You may have heard things like phrases like Industry 4.0 or I4 and the fourth industrial revolution. Kind of things a bit like that, a bit about an explanation about what's happening in the industry as a whole. Delving into the Solidworks solution side of it, how Solidworks is basically partnered with CAMWorks in 2018, how that actually is kind of shifting the industry somewhat. And then basically we'll look at some of the what's new functions as well, and how Solidworks and CAMWorks have actually developed things towards that goal of Industry 4.0 and everything else. And lastly, we'll also look at a new product that Hawkridge actually signed on with this year. It's not new to us in general. We actually, a reseller of ours that we partnered with for a while back, we ended up purchasing, called Centronics Midwest, and they were supporting it for a long time. But we're looking at, just to introduce a few of you guys to some of maybe the DNC side of things, machine data collection, and how that maybe ties into the whole Industry 4.0 system and everything else as well. So with that, we'll get started here. A few things. If there are any questions, you should see a questions panel. Everyone is muted, so if you're trying to talk to me, unfortunately I can't hear you and no one else can hear you. So if there are any questions, put them in the chat window or the questions window, and we can get them answered for you. I'll stay on at the end of the webinar and basically answer some questions. If it's more in-depth, if it's more of a technical support question, then obviously contact tech support and get your solutions figured through those guys. But I'll be honest, I'll be on here answering questions to basically get you set up. So we've run all of those. Essentially, the agenda today is basically looking at what is going on in the industry as a whole, looking at how Solidworks is basically changing the way manufacturing occurs, and then looking at what's new in the software for 2019. So essentially, where are we at today? We've got a lot of different digitized systems. We've got ERP systems for enterprise planning. We've got MRP systems for manufacturing, resource planning. I've just got a question here. Volume is too low. Just make sure your volume's turned up. I'll make sure my volume is cranked on my end too. But basically, we've got a lot of different digitized systems. A lot of our software these days is keeping us on our computers, on our laptops and everything else. We've gone away very much so from paper-based systems. CAD obviously, and CAM as well, being through the major ones in the manufacturing environment. With all of that, we've got a huge amount of data. We've got customer records, we've got purchasing records and financial records. We've got all of our CAD data, we've got all of our simulation data, we've got all of our manufacturing data, our setup sheets, our G-code, and a whole bunch of different stuff. Now, usually, you end up, because of all of those different products, and often they are separated products. Essentially, your CAD is, in typical fashion these days, there's still a lot of people that are using a separate tool or separate software for each of those different solutions. What that usually results in is a whole bunch of meetings where everyone's going for discussing any potential issues. Everyone has to be pulled off of the shop floor or pulled out of their office and things like that just to have a meeting. And sometimes there's meetings about meetings and everything else. And then you've got emails in your inbox, and it's pretty overwhelming, just the amount of data and the amount of information that gets thrown at you all of the time. Essentially, what Industry 4.0 is trying to do, and what the goal of it is, it was originated in Germany, but essentially the goal is to try and connect machines, people, devices, and systems using the Internet of Things, basically the IoT. With the interconnectivity between machines, people, systems, and everything else, you can garner a lot of data from that. So you can draw all that data into an environment, but rather than having to look at some bar chart or spreadsheet or kind of analyze the data that you're receiving, what you want is the right data in front of you, and it wants to be real time. It doesn't want to be a week out of date or 2 weeks out of date or a month out of date. It needs to be basically right at your fingertips whenever you need it. Third portion of the Industry 4.0 is the support. Essentially, the goal is to have different systems to assist humans and humans to assist different systems. So basically, if there was something like an unpleasant job or just something that isn't particularly rewarding for the operator, or something that's just difficult, or it's just labor intensive and things like that, why don't we get a system in place to be able to take that away from the human and basically put it into an automated fashion? And the same goes the opposite way. When systems fail or when systems run into an issue, you have to have a human there to know what to do in that situation. So there's kind of a connection between the way the operators are and the way their machines and devices and the systems are running. The fourth portion really ties back to that meeting point that I just made. When you have a system currently that's all this data is coming at you in different spreadsheets and documents and presentations and meetings, you're essentially being pulled away from your main purpose, unless you're a manager of doing all that sort of stuff. Decentralization, essentially what it means is you've got a lot of systems in place to manage how those situations occur. So if you are running into an issue where production quantities are low, maybe you have an automated system that fires up another line or something like that, or maybe you're overproducing and it shuts down a separate line or something like that. Rather than having a meeting to discuss all that, try and have some sort of automated system that goes, okay, based on sensors, based on certain inputs and outputs, do this for me. Basically, in a nutshell, what Industry 4.0 is trying to do is trying to integrate processes and systems together so that everyone is working on the same data, the same files, using similar systems or something that's familiar to everybody, automating the difficult, unpleasant tasks, taking away that stuff so that we basically become more of a monitoring situation, but that frees us up to do more complex stuff. We also want to give the right data to the right person at the right time. The last thing everyone wants to be doing is running off data that's months old, because you're not making a decision based on real-time situations. And basically the whole goal of it is to use sensors and that data is to drive an automated decision-making process so you can streamline everything. Now, Industry 4.0 really is going to be kind of pushed forward by automotive, aerospace, and high-end medical stuff. That's the typical situation. And then it filters downstream to a lot of the mainstream manufacturers as well. But there's also a huge bunch of other trends that seem to be going on. There's a lot more what they call onshoring, essentially bringing manufacturing back to North America, back to somewhere closer to you. There's another term called nearshoring, where you're not using vendors or suppliers which are right across the other side of the world. You're using them within a reasonable locale, basically within a reasonable distance. But there's a lot more manufacturing tending to be coming back to the local areas, primarily because you want to be more responsive to those needs. In a situation where that might be an example for this is, say for instance, I have a mold that I'm making. I shipped it out to the Far East. They did all the work for it. They send me all the parts. But then there's an issue with the mold, and it comes that I need to change the mold, or I need to change the part, which changes the mold and everything else. Well, if I've got my manufacturing done in the Far East, I might have 20,000 or 50,000 parts in shipment already on the way to me, and then I've got 50,000 parts which are all basically either scrap or old, or I have to deal with them somehow. And then you've got to stop production in the Far East, make your change, and then you finally get your changes back several 100,000 parts later or whatever. There's also a trend to sell services rather than products. Obviously, there is always going to be a market for products. We're going to look at an example of a Hifi. You're not typically going to rent a Hifi from somebody. But things like people like Rolls-Royce used to sell jet engines to people. Now they don't do that. They sell the hours used, and then they basically do all the service work themselves and keep things as a service rather than a product. There's also a lot of product customization. Things like you can go to many of the automotive manufacturers these days and ask them for a specific trim or a specific paint job or all sorts of different stuff. One of the big things of big challenges for kind of mass production was always, well, the Henry Ford thing, where you can have basically any color you want as long as it's black. Well, that's not the way people buy things these days. People want their own customizations. They want their own special take on some product. And really, Industry 4.0 leads towards, okay, well, how do I get mass production that's also customizable? And looking at the car market, essentially they're doing that right now anyway. There's also a trend toward cost reductions. Some of the big box stores and Amazon and people like that are also setting precedent with cost. People are expecting things at a much lower value now. So there's different cost reductions that may be coming in. They may be bringing, major manufacturers might be bringing manufacturing in-house rather than using a bunch of job shops and things like that. Or they put the pressure on their suppliers to kind of squeeze the cost out and things like that. And I thought I'd just kind of take a quick look at cost, because cost is one of the biggest driving things. Essentially, cost of a product is built from the materials that you use, the labor that you have, any overheads, things like utilities, depreciation of machine tools, things like that, and general supplies that you can't really attribute to a particular task. And then there's also period costs, things like admin expenses, rent for the buildings and office supplies and things like that. So all of those go together. Now the factory overheads you can do some manipulation of. Period costs are generally quite fixed. But you've got materials and labor. Now you can't really change too much on materials. The materials that require for the job or the design need to be those materials. And obviously you can go and try and find a slightly cheaper supplier of that equipment or material and purchase that, but then you may run into quality issues and things like that. Some of the main goals of reducing part costs might be minimize scrap and rework. That's an easy one to do. Try and find all of your potential for scrap. Where's all your situation? Where's all your money going into chips rather than going into the product? And then also implementing some lean manufacturing principles or just-in-time practices and things like that. So you can actually try and save on materials and storage, even things like warehouses and warehouse space all take up certain things. How can you do just-in-time practices and things like that for it? In terms of labor, salaries really need to be competitive. If you start axing salaries, I'm pretty sure you're going to lose staff pretty quickly. So to keep a good workforce, you have to pay them sufficiently. But further to that, you basically, to reduce the product cost, you can reduce the product development time. Now, if we look at a typical product development cycle from years gone by, it essentially looks like this. You do your design work, you do your simulation, you prototype, you validate it, you revise the model, you go back to a review phase, you go and change the design, you rerun your simulations, you re-prototype, and then you eventually get to manufacturing at the end, and then you may even go through a manufacturing process where, okay, well, we can't make this in-house, so you have to ship it out, or we have to basically adjust our parts to make it manufacturable. So it's a sequential process. Usually involves multiple different softwares. You could be using a CAD package, a simulation package. You've got softwares for prototyping, and then you've got softwares for manufacturing. All of those require multiple different files, different file formats, and everything else. Design changes become problematic because you've got to go through that loop all the time. And essentially you can lead to unnecessary outsourcing because you may have designed something which you, unbeknownst to you, couldn't make in-house. You have to ship it outside. And that last one was really kind of a simplified version. Yes, design is design, but design includes conceptual design, includes industrial design, mechanical design, electrical design, PCB design. Simulation might have linear static stress analysis. You might have nonlinear analysis, flow analysis. Prototyping and validation may include 3D printing. It may include CNC machining, breadboards, and things like that for electronics. You've got technical documentation to also produce. You renderings for marketing materials. You've got product manuals to produce. You've got inspection documents to create, and then you've got manufacturing right at the end of it. CNC machines, 3D printing, electronics, and production electronics, and production electrical, and all of that is kind of underlined by PDM and the review process. So what the SolidWorks ecosystem is trying to do is trying to condense all that so we get a shorter product development time and a lower product development cost. Essentially, what we can do is we need our designs. Our designs are the key things. That's where SolidWorks' bread and butter came from, the CAD side. They were one of the pioneers of parametric design, and basically since then they've been improving on it, and spreading out into certain different markets. Now, you've got Composer, you've got Visualize for technical documentation. They're running the SolidWorks models in a separate environment so that you can do your technical documentation but still maintain that link to your CAD file. So if there is a change, it propagates through. Prototyping and validating, they introduced 3D print drivers and things like that a couple of years ago. They've got simulation and tests and things like that. There's a lot of that stuff, the validation side that isn't inside of SolidWorks, but it ties into the same ecosystem. Simulation, flow analysis, and everything else. Do you run a flow analysis and then, okay, well, you realize there's a rev change, or someone changed the cooling fan because they couldn't find a purchaser, or the purchaser couldn't find a particular spec of fan that they needed, so they changed the model, which needs different hole positions and things like that, which all goes to change manufacturing data. And basically the whole goal of this is to try and get everyone on the same page using the same models and the same environment, so it becomes a bit more familiar to everybody, so you don't end up having to learn 15 different softwares, and so that everyone can communicate to each other. So the way I see it is there's been a big shift. SolidWorks decided basically taking a CAM system on board and branding it with SolidWorks. They did a huge change with a parametric CAD. They realized ease of use was number one. You got to get people using it. You got to have people finding it easy to use, and that's really where SolidWorks' strengths boil down to, is ease of use and parametric CAD. Now they've started venturing out. We've got parametric CAM. So our CAM data, our manufacturing data, lies on our SolidWorks model. It doesn't lie on a third file or a fourth file out of the system somewhere. So we reduce our file counts because we're not having to have a toolpath file, a CAD file, and our G code. We end up with our part file and our G code. It also promotes collaboration between staff and teams. And what I mean by that is every seat of SolidWorks on subscription in 2018 had CAM enabled in terms of SolidWorks CAM standard. What that allows engineers to do is understand more of the design, the manufacturing side, because I'm sure there's a lot of people on this webinar that may have come across a part that just wasn't manufacturable. It came out of the engineering house, and basically there was no way you could produce it. The rads were too small, or something was just square corners and things like that. Having a CAM tool inside of the CAD tool promotes an understanding of the engineering side. So it's not just to toss it over the fence to the manufacturing team and let them deal with it. It's more of a team effort to get a product out. And because everyone's working together as a team, you get shorter development times. The other thing that's changing the game really is because of Solidworks CAM being integrated inside basically in every seat on subscription, you've got a CAM tool out there. There's also this trend of, okay, we're going to do 3D printers and everything else. And the CNC machine tools used to cost hundreds of thousands of dollars, and they still do, but there's also a more entry-level machines and things like that. So, and those don't cost a huge amount. You can bring one of those in-house, start controlling your own manufacturing, controlling your own lead times, controlling your own part quality and cost, rather than outsourcing it. And by companies doing that, it changes some of the way the industry is set up in terms of job shops. Maybe there'll be fewer job shops because there's fewer businesses. So job shops also have to then adapt to the changes. You've got to be more efficient. You've got to be providing a service quicker. So rather than being late on delivery, be early on delivery and things like that. You need to be changing the game to stay up with everything that's going on here. So we're going to look at an example. This is where we're going to start looking at some of the what's new. And I just thought of an example. I recently bought some Hifi equipment, and I was like, well, that's a perfect example of multidisciplinary teams. We've got things like the CAD designers, we've got industrial designers, we've got flow and electronics cooling and things like that. You may have some 3D prints for if you're doing like metal printing of heat sinks and things like that. So we're going to look at an example of that. You've got sheet metal fabrication, you've got CNC machining, you've got some routing for the wood speakers and things like that. So there's a whole bunch of different departments involved. And even just putting the models together for the presentation was difficult. Things like the rads on the sheet metal there, you want to make sure you've got a nice clean line, and in your finished result, the last thing you want is a big old step change and things like that. The industrial designer will have a fit. But basically, your manufacturing data is directly impacting all of those other different things. And typically, in an old system, your manufacturing is one of the last things in the process. So by having this and all of your details up front, you know exactly what tools you can use and what sizes you can use. You're working on the same data. So any changes that do occur basically propagate, and you don't have to reprogram things and deal with revisions as much. So in this particular example, like I mentioned, there may be industrial design, there may be mechanical design for the actual housing, there's PCB design and things like that. You may have stress analysis if you've got certain loads on it. If you've got a heavy power supply or something like that that's pushing down on it, you want to make sure it's not something super thin and flimsy sheet metal that's supporting that, so you might have stress analysis. You've got cooling. Those things run stupidly hot sometimes, some of those MOSFETs and things like that, so you've got cooling issues. When you're doing prototyping, you've got to do sheet metal, you've got to do machining, you've got to do your electronics for your breadboards, make sure you're actually going to expect the results and that you get out of your electronic design. You've got marketing images, you've got to get the people interested in the product before it's really developed. Product manuals, so you got to supply them with a documentation to say how it's being used and things like that, what's what. You've got inspection reports to produce for basically checking on manufacturing tolerances and things like that. And then right at the end, we've got the CNC machine, 3D printing, and all the electronics production. So on to the good stuff. What's new in 2019 in SolidWorks CAM? So I've got a couple of spreadsheets here, a couple of PowerPoint slides here that just highlight some of the key points. We'll take a look at them in a second, but essentially one of my favorites is your ability to associate strategies to machine selection. That for me is huge. Say for instance, you have, in this case, we've got sheet metal, we've got maybe a laser in the shop, we've got a router that's cutting all the wood for the speakers, and we've got a CNC mills, 5-axis mills, and things like that. I want to be able to control all of those from one set of settings or one database. I don't want to have 15 different databases, everyone running their own thing. I want to basically keep everything associated together so that when I select a particular equipment, it automatically goes and selects strategies associated with that equipment. Corner arc feed rate slowdown. So if we're running into rounding issues on corners and things like that, we're nicking off the corner just because feed rate changes, we can actually now program in slowdowns for corners or arc moves. You can edit hole conditions, another huge one. If I'm doing holes on or counter bores on like an inclined slope, how do I go and machine those and stop the drill from wandering? Well, I have to kind of basically put them at the top and do them as a first stop rather than kind of halfway down after the slope is being machined. So we've got the ability now to edit hole conditions. You can now turn on the display of contain and avoid areas. So when you click on the operation, it shows you what the avoid area is or the contain area is. There's now functions for long code drilling. So what I mean by that is rather than doing a CAN cycle like a G81 or a G82 or a G83, it will output your Z move, so Z plus, Z minus, Z plus, Z minus, that type of thing. So now there's a little switch in the software to go and adjust that. There's an updated edit toolpath function. This was one that was hidden a little bit. Not many people knew about it. It's kind of buried in the old system, but they revamped it and put it in a nice little interface. Curve features, we now get CNC compensation control and chamfering options for curve features as well. You have in Solidworks CAM, if you're using the professional version, you've got volume mill. There's now a zigzag function that will basically switch back on itself rather than doing the high feed moves across to the opposite side. And we now have tolerance-based machining for turning. On top of all of that stuff, CAMWorks has been busy. What's new in CAMWorks, essentially, we now have support for quad turret mill turns. Yes, that's a turret on the left at the top, a turret on the right at the top, and a turret on the left on the bottom, and a turret on the right at the bottom as well. So we can now have 4 sets of tools cutting my parts. We can use pinch turning, so we can actually have 2 tools cutting at the same time, doing like an OD roughing or something like that, running at much higher feed rates. We have control for relief angle now, so rather than gouge checking on the X and Z plane only, we can now actually have gouge check in the Y axis, so we can check for tool relief and things like that. There's a new 5-axis swarf machining strategy. Volume mill has a zigzag capability in 3-axis as well as in 2.5-axis. You've got rest machining capabilities now as well in volume mill and 3-axis and holder checking, which are fantastic. And you now have tolerance-based machining for mill turn. And the new one of the big ones, is you can actually now purchase an additive manufacturing module as well, which we'll take a quick look at and how that ties into what the industry seems to be calling hybrid manufacturing and things like that. So let's take a look at some of those. Now, I've got a nest here of the speakers. So this is a router that we're dealing with here. I've just set a few different machines up in my database. So I've got maybe a Tolmac, a Haas, a router, and a laser. And I want different strategies for different equipment. I don't want to be having to do constantly switching all my settings around between the different machines. Now this is different milling type equipment, but the same could be used for mill turns. Say for instance, you've got a mill turn with a C axis and a mill turn with a Y axis as well. You might want to save strategies associated to different types of equipment in terms of the mill turn. So automatically always do free moves on my mill turn. In my Y-axis machine, I will automatically do fixed because I've got that Y-axis capability. I can run it across the part and go from there. So you can actually save those settings back to the database and reuse them based on the machine-specific stuff. So I've got mine set up for router, and the key difference in here is you will now see in your database there's a default feature strategies. So what I've been in and done is I've basically got a bunch of different strategies which are my defaults for different equipment. So my default settings are here, but I created one. I just copied some of the original ones, and I went through my database and set my router strategies to automatically do things like a dado, interpolate circular pockets and things like that, and chamfer curves and all sorts of different stuff, ramp on the perimeter. For my laser equipment, I want to use different strategies. So now I've got different strategies that maybe select different curve thicknesses and things like that. And then I've got my milling strategies, which are my rough and finish. So this is really where it is, and this is how it's linked to the equipment down at the bottom here. So this is the actual machine that is linked to in your options. And the way you set it up is you go into your machine. So if I go into my machine up here, you have this default feature strategy. So my Haas here might have milling strategies associated to it here. My router has router strategies, and my laser has laser strategies all associated. So what that means that I can do is, running the same database, I can basically hit extract machinable features on here and basically generate router information. So it's going to use all my strategies, my predefined settings, go and generate a program for my router. So it's just running the feature recognition. That's nothing new. We've had that for a long time. But now it's doing everything in terms of the way I want to do it on that router. I can generate my operation plan, generate my toolpath, and simulate. And now I've got router strategies to go and machine all that stuff out. Alternatively, I've got the sheet metal housings. Now in here, I might have a laser. I've got things like all the sheet metal for the amplifier covers. I've got little heat sinks and switch plates and a whole bunch of different stuff in here. So heat sinks there and all sorts of different stuff. So what I can do in here is I've just set this up for the machine. I've already gone and defined the stock and stuff like that in here, but essentially I can recognize the features now, and it's automatically going to trigger different laser strategies now. So again, I don't have to have separate databases. I can have one database with all of my machines, all of my equipment in it, and basically program them differently. So basically, that's a fantastic option that they've introduced. It was one of the ones I actually requested, which is why I love it so much. But we also get that arc slowdown that I mentioned. So in your feed rate controls, if you're finding that you're rounding corners and things like that, what you can do is automatically slow your feed rates down in the corners, and you can control the angles and stuff like that it works to. But it'll actually run down and slow down a little bit before the corner, and then go and change the corner at a low feed rate and pick back up again to the regular feeds. So now there's a lot of little slots and pockets and stuff like that, so it looks like it's still running, but it shouldn't take too long here. Way easier than having to deal with a DXF and things like that. I can program routers and lasers and plasmas and all sorts of different stuff on here. So essentially the software is a milling package, but with certain requirements and certain restrictions and things like that, we can certainly run different types of machine tools out there. So just running the milling package. So you can see it's now determined laser strategies for all of these. So I'm running a tool list, which is basically some smaller sizes of end mill, which essentially represent the curve thickness. But now I can go through, generate those operations for my laser, and running exactly the same thing. And that corner slowdown function is where you'd expect it on the feeds and speeds. You can enable the corner slowdown or the arc feed rate. So every time it hits an arc, you can specify the minimum feed rate, maximum feed rates, or every time it hits a sharp corner, go and reduce the feed rates down here to these values down at the bottom. And then this is the threshold angles and things like that. So that's the new arc slowdown function. What we're going to look at next is looking at machining the body of this digital streaming unit here. So one of the new things, rather than using CD players and everything else these days. Everyone's in the hi-fi industry is leaning towards digital streaming, connecting YouTube and everything else to your phone and running everything off of your phone and everything else. And this is a housing to basically house that sort of stuff. So we've got some switch gear in it. We've got back panel comes in here and things like this. Got some slots for that. We've got some slots for things like cable routing and things like that. So in here, I've just ran the feature recognition, did a great job of finding a bunch of different types of features in here. The first thing I want to show you is, the hole adjustment option. So I've got a hole down here. Now this is an example where I could do it after the fact, but say for instance I'm dealing with something like this type of geometry where I've got a slope here and I'm trying to drill a hole in a slope. I don't want my drill to wander, so often what I used to have to do is have to go and manually create a sketch, put in a sketch at the top of the pot, set it as a hole feature, basically set the depth and everything else and programming like that. What we now have is an option just on the right click menu to edit the end conditions of the holes. So I can actually go in and say, actually, rather than going from here, start from up here, so I can now drill it and tap it this full way if I wanted to, and then I don't have to manually define anything anyway. Now this can also be set as an automatic setting in your options menu. So your options menu over here has an option to automatically extend all the holes to the stock. So if you're running into this quite a lot, you can check that on, hit apply, automatically get it to switch them all, and you can always just uncheck it and hit apply if you don't want it to occur on a particular file. So you can set your preferences up here to what you find most commonly, or you just leave it on and leave it off and then turn it on whenever you want to use it. But we can now adjust the end conditions for holes to start at different locations and go to different locations. So say for instance I wanted to drill a hole all the way through my pot here because I want to do it. I've got a counter bar on the back and I want to indicate off of that for the next op. I can adjust all that and make that happen automatically using those new functions. So let me just generate the operations for those holes here, and you'll see now that the operations now start drilling from the top of the pot rather than down in the pot here. So that could be something I want to make sure I'm doing. But now we also have that control for when you've got your post selected. As long as you post supports it, you'll now have your control for CAN cycle outputs in this window here. So I don't have a post selected right now, but basically you'll have the option to switch for CAN cycle output versus non-CAN cycle output. But obviously your post needs to actually support that. So once you've got your post selected, you'll have a function down here to say CAN cycle output, checkbox or unchecked. Unchecked, it will output the Z moves. Checked, it will output the relevant CAN cycle and things like that. Now, with this type of geometry, this thing's about 2 inches thick, I believe. This type of geometry is quite a deep pocket. There's a lot of material to remove. So rather than using the 2.5 axis, I'm going to use some 3-axis roughing. So I've gone through and just set up a 3-axis roughing strategy that I like to do. And in this case, I'm going to actually rough it 3 times, big tool, middle tool, small tool, and then come back with a finisher and go and machine this stuff. So here's our 3 operations for our Z level, for our area clearance, sorry. So I'm going in with a 3/4 inch tool. I've got my volume L pattern checked on, and you'll see there's now options in here for holder avoidance. So it will actually check. So if I don't have enough reach on my tool, because my holder might be coming into play here. So if I go and say, okay, my holder isn't very long, let's go say 1.5 inches down here. We'll just stick everything as far down as possible, but I turn my holder on, you'll see what it will do. It will actually go in and check whether the holder is going to collide with the wall, and then automatically go and say, okay, well, I'm not going to go as deep in that particular region, but I'm going to go deeper where I can do. So on the floor where there's a big open space here, I don't want to just stop right where my holder is, even though my holder is kind of machining the wall here. I don't want it to just stop at this position and machine everything to that depth just because my tool hasn't got enough reach. So what it will actually do is it will go in, machine it to the depth where it can do, and then it will machine up to basically a point where it will holder check, and now you'll see it's not going anywhere near the walls there because my holder would hit in that region, but it's fine in the middle, so it goes and roughs all that material out. So that's a great new option for kind of doing this type of work where you may have short tools just to increase stiffness, but you want to go in with a volume mill style toolpath. So now you can go in and check the holders. Let's just set that back to 2.5. We've got a big tool, so we've got a fair amount of reach on it. And what we're going to do is come back with our smaller tool in here, and there's a whole bunch of new functions as well that I didn't mention earlier for things like tapered tool support and barrel tool support and things like that. Basically, you can now add tapered tools, tapered shanks, and things like that in here, so you get a more accurate representation. But in here, the big one for me is I can now do rest machining on volume mill. In previous packages, previous versions, volume mill would always go and just machine to whatever the stock size is, regardless of whether you try to include the rest machining on or not. But now I can tell it, okay, go and factor in all of this stuff in here, go and factor in my previous operation and output another volume mill toolpath based on that. So now it will actually recalculate my volume mill toolpath. It will first calculate my first area clearance, then it will calculate my second area clearance to see what's being machined and go and machine any leftovers. So in this case, my 3/4 inch couldn't get into the corner right down here. It's a bit too small. And it's actually machining all of that leftover because I didn't generate the full toolpath. But then I'm going in again and machining the tiny little portions out with a 1/4 inch tool, basically to get my material out of the stuff down here. So you can now implement 3-axis machining with rest machining on volume mill in 3-axis. So now it's going to go through and generate those. Another function of volume mill that they've added, and this one's available in Solidworks CAM Professional, in the volume mill in 2.5 axis and in the volume mill 3 axis, is the zigzag function. And I'll explain a little bit about what that is here. So in here, you'll see on your area clearance tab, there's now the ability to do zigzag. Now I'll show you what it looks like before. So we'll just get it to say here, and we'll walk through the movements here. So it does its big sweeping motion here, but then it does a high feed move back to the beginning of the cut, and then recuts again, comes back with a high feed move. That high feed move isn't essentially doing anything. It's not cutting, so that's why it's a high feed move. What the zigzag function will do is it will remove that, basically that high feed move, and loop back on itself. So rather than going across the full width of that slot, which is essentially wasted cutting time, you will now get the ability to arc around one way, loop back on itself, and arc around the other way. So you'll see the movements are, okay, here's my movement forward like it was doing before. Now it comes out, and then rather than going across the part, which is a big wasted transition, it actually comes back on itself and cuts back on it. So it zigzags now back and forth across the cut in here. So that's another new option that's available in 3-axis and in 2.5 axis. It's the same checkbox that you would use for your regular zigzag pocket in, pocket out type pattern and things like that. So that's another new function. If we look at the front of the unit here, we've got a big curved feature right across the front here, and essentially what we've got is a 3D curve feature. Now, we could always put in these before. If we pick on a particular setup, we had the curve feature. That's nothing new. What's new in the curve feature is a couple of things actually. So we can use a 2.5 axis curve feature, go in and tell it the geometry that I want it to follow along in this case, and I can go through, set my depth up accordingly. So maybe we'll just do it, say 1/8 of an inch. Click on the option here, go and use our database settings, standard stuff. Go and grab our countersink tool. What we now have control over is we now have control over the CNC compensation and the toolpath center compensation. So prior to this, it was always grayed out. You couldn't basically turn on the compensation for a curve feature. But now I can actually enable it or disable it. In this case, it doesn't really make any sense in this example. It's trying to do compensation, so it would actually gouge the part and cut it further out. So what I can do is just turn them off in this case and run it center line cut all the way down the middle of the V groove there. The other thing that's new to curve features is the ability to turn on the chamfer machining option. So now I can actually, on a 3D curve, if I'm walking up a part, across a part, and then down a part for a different depth, for instance, if I've got a 3D curve, I can now do chamfering on the 3D curve. This option was previously grayed out. In this case, it doesn't really make much sense in this particular example, but I can then go and now turn this on and specify my length of my chamfer, specify the clearance off the tip, and tell it whether I'm programming the shop, the virtual shop, or the outer edge of the geometry. And there's also an avoid allowance, so you can tell it basically if you want to avoid a certain amount of material, and if you want to kind of pull it away from certain geometry. So you can turn that on as well. So that's the curve features. In here, like I say, the main difficulty is in this particular part when you're modeling things like the radius in here. You want to make sure those rads and things like that are consistent across the board. You don't want things looking different from different models and versions of your parts and things like that. All of the design and the way that each of the individual parts intersect each other, like the back plate across here needs to meet up perfectly with this and everything else. That's some of the tricky challenges of this in the design side of it. And by doing this and working through different iterations and things like that of your design, you end up changing your model, and you may end up with things that might need to be 5-axis machined. Now, 5-axis machining can be notoriously difficult. In this case, what we're going to do is put in a couple of swath machining strategies, swath machining toolpaths here to go and cut these two chamfers on. The industrial designer went and said, okay, well, I want a big old chamfer on the front, make it look a bit more decorative. That's great, but then maybe maybe we didn't have a 5-axis machine, so okay, we look at it, we scope it out, we don't see that they're that expensive these days, we go and buy one, so we can bring this in-house. What we can do in here is go in and put in our features to go on machine. So I'm going to grab that, I'm going to use a standard 5-axis strategy to go and machine that, and we'll do the same for our bottom one here as well, 5-axis. Go and generate our operations for those, and you'll see the new function is on the pattern tab at the top here. So I'm going to just switch over to a flat end mill in this case. We're just going to run a swath machining pass right down here. So we're putting it in the machine in this orientation. But on the pattern tab, you'll see, rather than before, I had to go to my tilted relative to cutting direction, go and specify my tilt angles, go to my pattern tab and specify probably flow line between curves or flow line between surfaces and everything else. In this case, our new swath milling function, we go and tell it what our upper curve is. So in this case, my upper curve is this one. My lower curve is this one. If I make a mistake, I can easily just check the box and it will switch them around for me. And it goes and machines our curve there using swath machining. Same thing with this one on our top of our geometry here. Just basically go in, switch it over to swath, and you can't really get much easier than that in terms of 5-axis machining. Select 2 curves and you're done. Super quick to generate, and here's my 5-axis swath toolpath to go and machine that with all of its built-in capabilities and everything else. So super easy to do, nice new features, and you've got now more control over some of the stuff as well. Down at the bottom here, things like machining the floor features as well, and things like that. So nice new option there. Say for instance, we're developing our new product line. We've realized there's an issue maybe with some of the interconnects that we've been using in the past. We realize there's a bunch of EMI or there's a bunch of issues with them, so we want to go and develop our own different binding posts for our equipment. I've been through here, programmed this, and set it up so that it's for our mill turns. So we've got our threading coming in, we've got our entire process. It does a transfer over to the sub spindle, and basically that's nothing new. What's new is the ability to specify multiple turrets. So we used to have 2 turret capability. We had an upper and a lower turret. But when you're talking about high volume production items like this, where you've got tiny little pieces, interconnect stuff, all that type of thing, things that need to cost pence to make rather than dollars, you want to maximize efficiency using things like Swiss machines and quad turret machines to basically crank these parts out as fast as you can. So in your tool crib now, you'll have now up to 4 tool cribs. So one for the upper left turret, one for the upper right turret, one for the lower left turret, and one for the lower right turret. And essentially, the simplicity of it, programming it in here, is we just go and select a tool from our tool crib and specify the holder orientation. So our tool crib now has an option up here to say which tool crib we actually are using on which turret. And then obviously our holder orientations would dictate what orientation that we're using for machining. So this is the rear on the main spindle. This is our rear on our front spindle, on our front turret, basically, near the main spindle. So this is coming in from the bottom and machining up. We have now our sync manager as well. Also, this was nothing new. We had a sync manager, but our sync manager can now synchronize those 4 turrets so that we can go and, synchronize the rear turret near the main spindle and the front turret near the main spindle, so that we're basically cutting the groove at exactly the same time. So we're not wasting time running separate operations, and we're basically kind of maximizing 2 tools at the same time cutting. And then we're doing our synchronization down here for grooving as well with the rear turret and the front turret for the sub spindle at the same time as well. And we've got our weight codes in here to synchronize all that stuff. So, and we also have our time view for the main spindle, and you'll see the rear 1, front 1, rear 2, front 2 turrets, and where the overlaps occur and things like that. So the other things we can do now are pinch turning. So if, say for instance, I'm doing this OD profile, you program it exactly the same way, but now you'll see there's this, and it looks exactly the same way. You'll now see this simultaneous pinch machining option here. What that will do is when you turn that option on, it will load up 2 sets of tools in here. So you've got tool 1 and tool 2 with each of the ones in here. So I selected tool, the bottom tool for my front turret, and tool 1 is my basically my rear turret. So basically coming in together, machining these at the same time, roughing this out. And the benefit of pinch turning is you can crank up the feed rates. Basically, you can double the feed rates. So I've got 2 tools cutting at once rather than just 1 tool going at one time. So you can see now in this case, if I simulate this here, you can see the 2 tools coming in basically at the same time to go and machine that particular part right down. So we can crank up the feed rate to get these cycle times way down so we can save our cost. The other thing that we have in our tooling is, like I mentioned before, we have a relief angle. So before, when you're looking at your tools, we really just used an X and Z profile, so our tools never had a relief angle on them. But you'll now see on your inserts, you now have a relief angle, so you can actually specify relief angles and make sure you're not gouging with the leading edge or something like that. So now you can see the insert is actually tapered now, so I can actually gouge check with those as well and make sure that I'm cutting properly and treating my tools exactly as they are in the machine rather than just as kind of simple 2D shapes. So we now have that relief angle. So that's some of the new enhancements in Milturn. Lastly, we've got a new tool called CAMWorks Additive Manufacturing. Now, this is going to be a new module that you can purchase. Essentially, what this additive manufacturing software is going to do is there's a big trend in the industry towards, well, okay, we've got 3D printers now. 3D printers can now print metal. Well, okay, those metal printed parts may need high tolerance holes, they may need surface finishes and stuff like that. 3D printing metal, fantastic. No need to have to worry if this was a heat exchanger or a heat sink for a bunch of MOSFETs on my amplifier, for example. With 3D printing metal, I can get my cooling qualities, I can get more complex geometry, so I might be able to package things a lot more densely because I can boost my efficiency of my heat sinks and things like that. So what CAMWorks has done is basically partnered with Materialize. Now Materialize, they have basically a bunch of additive manufacturing processors. So a build processor to additive manufacturing is essentially like a post processor to G-code. It's basically what translates that particular geometry on the screen in here to the 3D print code that particular printer needs. Now I've been through and set this up. It takes a little bit of time to run through, but basically what I'm doing is I'm programming, in this case, support material. So I've got my print bed here that I'm going to go and print this on, but I've put in a raft. I just lifted it up a little bit off the table here to put some support features in there, just so that I've got my finished face and stuff like that. When I put this on my MOSFETs and things like that, I want the heat transfer to be as best as it possibly can be and the conduction as good as possible. And I don't want a kind of a rough face down at the bottom there. I want a nice clean machined face to transfer my heat. So what I've done is I've lifted the part up a little bit, and you can program all the support structures. So what Materialize is doing is essentially allowing you to program 3D printers from one interface, even though you might be running it on many different 3D printers. So you might have, when they release them, the HP Metal Jet. You might have a Markforged Metal X and that type of thing. Two of the printers that basically we have and we sell basically are those two types. Now, you might have multiple different 3D printers in your facility. You might want to basically run the same code but on different printers. Essentially, that's what our CAM tools do for our CNC equipment. Basically, that's what Materialize is doing in here. You have one method of setting the print job up, but you're outputting it to multiple different 3D printers based on the build processor, or basically the post processor for the actual G-code type thing. So in here we've been through, we've planned how we're going to print it, we've laid it on the bed, we've oriented it, we've added our support material, and in this case I didn't worry about too much the little undercuts in here. It would have done those as well if I wanted it to. There's a little kind of support material beneath these, but I just wanted it on the bottom here. And what I've got here is now CAMWorks has this CAMWorks machining option, which will immediately transfer the stock over to my CNC tool. So my stock now is set to an STL file, which is the STL file that I would have been basically printing on my 3D printer. So basically in here, I've got my STL file set automatically over here. And what I've done is I've just ran a face feature across the top over here to clean up that. So now I can actually simulate that, and I'm machining additive parts basically. So I'm doing a hybrid of the two. I'm machining 3D printed or hybrid machined parts basically. So that's what the new CAMWorks additive manufacturing module will do. So I can now basically go and 3D print and CNC machine in one software essentially, keeping everything in the one environment in here. My speed is set super low for some reason, so. But essentially that's what you're able to do now. Now, another product that Hawkridge took on, I know we're running a little bit over here, but I'll keep going here. If there's any questions, by all means, put them in the questions window. I'm going to keep going. There's not very much more. But tying into that in Industry 4.0, Hawkridge decided to partner with Predator CNC software. And a few of the functions are DNC, so you can actually communicate to the machine. You no longer have a guy running with a USB stick across the shop floor. You can actually set up all the machines wired or wireless and just send the files or call the programs from the CNC. But essentially, to have manufacturing data is critical to this whole process of how much does everything cost. So because you've got things like cycle times, how much is your machine time down? Now, what a lot of the big automotive shops have, and some of the high-end machine shops have, they have screens on their walls showing live production data instantly. Basically, all the data is being kind of captured from the CNC machines and basically put into pie charts, spreadsheets, and dialogues and things like that on the shop floor, so you know exactly where you're at for the day and what production quantities are at. So you can quickly glance, see where you're at. If you need to make changes and adjust your production strategy, then you can do so based on real-time data. Now, one of the common questions as well, we don't really need that. We're a smaller shop. We're not doing production work and things like that. We're not really interested. That's the kind of common thing that we get told for this type of thing. But when do you need to replace your machines? How do you know if your CNC machine is constantly in tear down because it's broken or something like that? At what point is it now no longer economically viable to keep running that machine, and it's taking you more money and time to fix than it is to actually cut parts? That's the stuff that collecting machine data can give you. The other thing may be, okay, you might have an operator that's potentially lying to you about, okay, well, the machines, and blaming the machine for this and this and this. How do you know if it's a machine issue or if it's an operator issue? Perhaps the operator may need more training. Maybe he's not familiar with that control, but he was kind of familiar with a similar control, but he's struggling with it, and cycle times are down and setup times taking longer and things like that. How can you get that information? Now, some of you may not know that your CNC tools are actually bilingual and maybe trilingual. So obviously we can run G-code, there's Mazax with Mazatrol and things like that, but there's actually another language in the background that machine tools can read. So there's been a kind of industry direction towards, well, how can we get that machining data off of the machine? So if you looked at anything like the Celos controls for the DMG machines, where they've got the Siemens control in the background, but they've got the Celos interface for all that sort of stuff. Essentially, that is the same thing, but we can actually apply it to all different machine tools using Predator. So Fanuc has a language called Fanuc Focus. Okuma has a language called Okuma Think. There's a couple of industry standard ones where MT Connect that Mazac and Okuma support, and there's a couple of ones, other manufacturers as well. But essentially what it allows you to do is collect data from the machine to say, okay, when did the operator push cycle start? When did the operator um, basically run it into setup mode and things like that? And he can have a little tablet, or he can have a screen or a computer at his station that goes, okay, I'm now in setup. He hits that button, or he scans a barcode and it reads all the data into the software, so he knows exactly what he's programming at any one time. All of that can actually be fed back into Predator, so that you can actually tell what the live tool data is, what the data is coming off the machines. There's a touch HMI interface that allows you to have like that tablet, and you can go, okay, automatically do a bunch of functions when I hit this little button on the tablet. There's a tool tracker, so you can track tool gauges and things like that, and where is that tool? So rather than having a guy that's wandering around the shop looking for a particular tool because another guy just took it out and started using it for no reason, you can actually scan barcodes on tooling and things like that, have it read into the software so it knows exactly where that tool is, where it's been used, and everything else. The DNC sides allow you to call up programs from the CNC machine itself, so you don't end up having a guy walking between buildings or spending time wasting basically your hourly rate walking between the office and the machine. You can have the guy at the machine doing his job, and he can just call up the program from the CNC, or he can go to the office and send it to the CNC rather than having to walk over with USB. There's also the CNC editor. That's the most common one. Basically, you can go through and edit your G code. CAMWorks has the NC editor as well. Basically, the Simco Solidworks Cam has the Solidworks Cam NC editor as well. But that DNC function really takes it to the next level. And you can store all of this in Predator PDM, which is basically a way of storing all of your manufacturing data, what tools you're using, your setup sheets, your programs, and everything else. So everything can be revision controlled together in one system. And with that, that's the end of the webinar. I hope you guys took a lot of the stuff there. There's a whole bunch of other stuff I didn't have a chance to include. But basically, go into your software, go into your tool or your help menu, hit the CAMWorks or the Solidworks Cam, and hit the What's New, and it will load up the dialog box or load up the PDF with all of the new functionality in here, so you can see exactly what's going on in here. So actually, one of the other ones I forgot to mention was tolerance-based machining is now supported in turning and mill turn as well as milling. So lots and lots of new enhancements. Solidworks keep pushing the development of this, and CAMWorks obviously keep pushing the development of this also towards that Industry 4.0.